We gotta chat, folks. Okay, so what was the exponential growth formula? That's what we'll call it.
Product parentheses
What goes in here?
1 plus R with T time.
Okay, so that's when things are going up by a certain percentage every year. That's normally what it looks like. Sometimes that number in parentheses, you can just simplify it. Like if it was a 5% growth, so it just looks like that, right? For 10 years or whatever. You can just add those together. Girls. Okay. This is also, you can use this for the simple interest formula. If you have like a savings account or something, maybe at the end of the year the bank says we're going to give you, 1% of whatever. That's probably a little bit high for a savings account. Actually, less than 1% would be more normal. But if it's simple interest, they just pay you one time at the end of the year. Compound interest is more common. And we did talk about this last year. I'm sure you kind of forgot it though. Compound interest is, like I think my bank pays me 12 times per year, like once per month. So that doesn't mean they give me like the 1% 12 times. They only end up giving you like 1/12 of your 1% each month. So you're getting your money a little quicker, but that ends up giving you slightly more money than simple interest because you're getting interest on top of, you're getting your interest rate on top of interest you've already earned. If that makes sense. So, the compound interest formula, see, you guys tell me if this rings a bell.
T.
Remember that? Okay, what's the new thing? What's different between this and this?
Okay, but how many times you're paid?
K, right. K is, don't ask me why they use a K usually. This book might use a different letter. No, they use a K. Amount of times compounded yearly. So if it's compounded monthly, this would be a 12. If it's compounded quarterly, how many times would that be?
4.
4 times. Daily, 365. What's another one? Semi-annually, I guess. That would be a 2. That's about all I can think of. There's not a lot of options they use. So let's look at an example. This is for simple interest. Let's say we had $1,000 and we invest at, 4% for 5 years. That would tell us how much we'd get. If we got paid once per year, this would tell us how much we got paid. Somebody plug that in the calculator real quick. Sam, you're up to bat. Who else has a calculator? Ava, you can get this next one.
$1,260.65.
Okay, so basically we made about $217. Started out with 1,000, we ended up with over 1,200. Okay, now if we compounded the interest, let's say monthly, then we're gonna put a 12 there and a 12 up here. We're still gonna go for 5 years, still have a 4% interest rate. Let's see how much better that does for us. So we did a little bit better. It doesn't make a huge difference. Why does this one make more money? Okay, that 4%, notice you're getting paid 12 times as many times, right, as you would have up here. Here you're getting paid 5 times, once per year. Here you're getting paid 5 times 12, so that's like 60 times. So it's 12 times as many as this. But your interest rate is only 1/12 of what it would be for each payment. The reason you're getting more money is because, like, after January, you're getting paid once. So you have a little bit of extra money in the bank. So when you're getting interest for February, you got a little more money than you would have. So you're getting your percentage on like $1,000, $1,001. Does that make sense? You're getting your interest on top of your interest. Following now? Now, you don't really have to understand that to do this, but you get just a little bit more money. It doesn't make a huge difference. It just adds you a little bit more. Okay, well, the more you compound it, the more money you get. Like if you got 365, if you compounded it daily, maybe this would go up to like 12, 25 or something. And the higher and higher and higher it gets, you might think as this approaches infinity, like 1,000, a million, a billion, if you compound it more and more, you might think this number might go up forever. It actually doesn't. It kind of starts to flatten. And it approaches a value. So this little formula right here, as k approaches infinity, this is how you would write that. As k gets larger and larger and larger. Well, as this k approaches infinity, what's this value right here going to approach? If you have like 3 over a billion or trillion or something, you know, what's this about worth as this number gets huge?
Less than 1 cent.
It approaches 0. Like if you divide by larger and larger, and larger, as k approaches infinity, this is approaching 0. So this, in parentheses, we got like 1 plus 0 basically. So in the parentheses, it approaches 1. But this number, as k approaches infinity, will just approach infinity. But what happens when you multiply 1 times itself over and over and over and over again?
Still 1.
It's still 1. So this thing is getting tinier and tinier and tinier. Why this gets huge, bigger and bigger and bigger and bigger. So they're kind of fighting each other. Like this is getting closer to 1. This is getting closer to infinity. So they kind of level off. And the value, as k approaches infinity, equals something they call e. Kind of like the number pi. It's about worth 2.72? I kind of forgot. I don't use this number as much. Come on, book. Well, here, let's do it this way. Everybody find the e. Your calculator probably says e to the x. Why don't you plug in e to the 1, because we're going to need to find that button on the calculator anyway, and see what it equals. I think it's 2.72.
2.7182.
Okay, yeah, it's about 2.72. Kind of like when we round pi up to 3.14. That's about what it's equal to.
So are we using e today? Yeah, I see it number 4 of that.
Okay, so when you compound like an infinite number of times, they call it compounding continuously. It doesn't actually make your money like go to infinity. It kind of levels off. So the formula is actually kind of basic. parentheses stuff, gosh. Continuously, is that how you spell it? The formula is just principal times e to the RT, so you don't even need the parentheses stuff. That's kind of how it works. Okay, so on number one, now we're ready to jump in. It says, gosh, I'm getting warm. Okay. Is it just me? I regret that my long sleeve shirt option. I'll close at least quantity.
No.
Are you cold?
A little bit.
I'm sweating over here. Okay. Okay, so on number one, they just want you to plug in 5,000 for n. This is the compound interest formula, basically. They want you to plug in 5,000 for n, and then write what you get, and then plug in 5 million. 1A. Why don't you guys all do it? Everybody try. All right. They rounded to like 5 decimal places. What'd you guys get?
I put 2.72.
Okay, you're gonna have to be more specific than that because they're trying to make a point on what this thing is approaching. So you're gonna have to be a little more specific.
2.718010005.
That's fine. And then the next one, yeah, plug in 5 million this time. Okay, what did you guys get for this one? 2.7 what? 1828. All right, so it went up slightly, right? So on B, they want you to compare that to the value of E. So on most calculators, you have to plug in E to the 1 to figure out what E, we just did that earlier. It was 2.718, I think something.
281. No, 18281.
18281.
Mm-hmm.
Okay, so it's extremely close to this one. I think this was like a 2 actually. Okay, so as n approaches infinity, as it's getting bigger and bigger, it is getting closer and closer to E. So what they wanted us to put, they wanted us to notice that it's about the same. What can you say about the value of E compared to A? They're about equal. Two is pretty much the same idea. They want you to give some decimals on A and then show that it's approaching E to the -1. Okay, which is larger, E squared root of 2 or square root of 2 to the E? Try to estimate before you use calculator. Oh gosh, I don't know how they wanted you to know that. Okay, E squared root of 2 e to the square root of 2 or square root of 2 e. Like 2.7 to the 1.4. It's probably like 4 and 1.7 to the 2. I'm thinking the second one's bigger. I was wrong. Alright, what's this about equal to? Maybe you guys don't know how to plug that one in, do you? Square root 2 the... yeah, we probably want it to be the... Okay, how about this one? Okay, so e to the square root of 2 is larger. That's a winner. Honestly, I don't know why they threw that one in there. Okay, number 5. Here we go. Jumping into money. Suppose you invest $1 at 6% annual interest. Calculate the amount that you would have after 1 year if the interest is compounded. A, quarterly, B, monthly, C, continuously. So, we're going to use the compound interest formula for A and B. So, we're starting with $1. Now, if we put a 1 in the front, is that going to really change anything? No. But, just so it all looks right. And we're supposed to compound 6%. So, that's going to go on top, 0.06. Quarterly, how many times is quarterly?
4.
And then out here we're going to put the 4 again, and then the t, they said 1 year, so it's going to be a 1. For B it's the same thing but monthly, so there will be a 12 there, and a 12 there. And for C, that was our little compound continuous formula. It's 1 to the 0.06 times 1. Okay, so since we're talking about money, where would you normally round it to? Probably. They actually, yeah. So if you round it to the second decimal place, the 1 cent place, they all come out the same. So they actually went to 4 decimal places, I guess. So you can actually tell the difference. So what is it to 4 decimal places? Okay, so this kind of shows you the moral of the story here is it's making a very small difference, compounding it. 4 times a year, 12 times a year, you get a little bit more money. And continuously, infinitely compounded, just get a couple. This is like 2 100ths of 1 cent. Okay, now, if you started out with more than $1, it would make a little bit more difference, but compounding doesn't make a huge difference, just makes a little difference. Alright, number 7, $100 deposited in a bank that compounds interest quarterly yields $107.50 for 1 year. Find the effective annual yield. Okay. Okay, we started with $100 quarterly. Mm. Um. Mm, mm, mm.
Did you put X in for R for the rate?
Okay.
Sorry.
What did we end up with? 107.50. Okay, so even though it was compound interest, they're asking what the effective interest was, basically. So, we're solving it as if it was just basic interest rate. We're solving it as if it was just a basic interest rate. So they gave me 100 to start with, 1 year, and I'm just going to solve this for R. Any idea, what would you guys do first, solve this? Right, get rid of that 100. Okay, anything to the first power is just itself, right? So we don't really need that 1 right there. Okay, and then how do I solve that for R? So whatever this comes out as, let's see, they rounded to 1/10%. Remembering good times.
I got 0.075.
Okay, what's that as a percentage? 7.5%.
Yeah.
So what probably happened was they said, we'll give you like 7.2% interest compounded quarterly. And effectively though, you're just getting 7.5% interest. So they probably said something like, we'll give you 7.2% or maybe even 7.3% compounded quarterly, which just makes your interest a little bit better. So we ended up getting 7.5% in simple interest terms. Okay, so compounded quarterly gave them a little bit more money, but it's the same thing as just getting a slightly better interest rate on simple interest.
So, since it was compound quarterly, why didn't we put a 4 in at the top?
Okay, because I wanted to figure out effectively what's the base percentage they're getting. So I just used the basic exponential growth simple interest formula.
Okay.
To figure out what that percentage would be at a simple interest. That's what they mean by effective interest. Like basically what are you getting per year? 7.5%. Even though they might have said this, that translates to this.
Okay.
Okay, something like that. So it doesn't help much, is kind of what they're pointing out, I guess.
Okay.
I don't know if that's what their main goal is, but. Okay, number 9, with which plan would an investor earn more, plan A or plan B? So plan A 6% annual rate. So annual rate just means you're getting paid once per year. That's the same thing as simple interest. Compounded annually, that's just simple interest over a 10-year period. So it doesn't really matter how much you invest. So we can just kind of leave like a blank up here. We'll pretend it's like a 1 or something. But we get 6% interest for 10 years. Okay, that's plan A. Plan B, we're getting 5.5% compounded quarterly. So 0.055, gotta move the decimal twice, 5.5, compounded quarterly. Okay, which do you think will make us more money? Okay, let's find out, you gotta plug it in. Split the work. Lydia, how about you get the first one, and Trey, how about you get the second one? Let's go to like 4 decimal places, will probably be good enough.
1.7908.
Okay, so that kind of means we're making 79 cents on each dollar, because I just put a 1 up here. So for each dollar, we're gonna make 79 cents. That's pretty good. It's 10 years, a high interest rate.
1.7267.
Okay, and then with Plan B, we're only getting about 73 cents on each dollar. So, again, what point are they making here? Okay, Plan A1, that's the answer. Okay, the point is, this is a slightly better interest rate than 5.5% was. 6% is better than 5.5%. And it doesn't matter that this one's compounded quarterly, it doesn't make up the difference between the interest rates. So 6% is better than 5.5% compounded quarterly or monthly or daily even. You can't compound enough to make up the gap there.
If they were the same amount, like 6%, both of them, then would Plan B?
Yeah,
be better?
Plan B would be slightly better.
Okay.
It'd probably be like, I'd guess like $1.81 or something,
Okay.
instead of $1.79. I'm guessing, but somewhere around there. Okay, number 11. Suppose that 1,000 is invested 7% interest compounded continuously. This one's a little bit straightforward. I don't know why they. Okay. Anyway, they just want us to use the compound interest formula. You guys recall it? E to the RT. There is no K on this one because it's continuous. But the only 2 variables, the interest rate and the time, those are multiplied together. So we're starting with $1,000, so it's 1,000 times E to the 7%, 0.07 times 5 years. So if I was doing this, I would just do that part in my head. What's 0.07 times 5? If you guys don't know that. It'd be 0.35, so you can just plug that in. Or if you're not confident, you just plug it in like that. That's a decimal, that's a time symbol. They rounded to the nearest cent. We're not comparing. jinx yourself on the evens.
No.
It did take a while, didn't it?